Okay, this was on the Science Channel, and they were talking about Einstein's theory of how gravity is from these, it's like a big wave of a piece of fabric, and this crushes it, and everything has to roll down into it. I mean, I'm telling you, it's nonsense. Now, I've tried to contact Science Channel. I've never had any response from them, but my theory is right. As every time you have a positive and a negative like this, and it's moving through space, and they are, and they concuss with these things that are just floating around, because these are light particles out here too. You're going to tip, and they're going to spin. They're going to tip and spin. So this is going to naturally make they're going to end up having a right-hand spin. That's just, and I'll show you the evidence of it, how light makes a right-hand spin. And I think it's because it bounces off. It like rolls over the rest of the particles that are in front of it. That's all I can tell you. Because one of these is concussive, that one, and that one's just dead weight. Concussive dead weight. So as it comes forward, the concussive part is going to push away this way. The dead weight is just going to follow it. So that's how I'm figuring that everything started to spin. Now let's look at what happens in the actual Milky Way. All right, I know this is a lot to take in. It's sort of new to everybody because they are not thinking correctly. Now, here's the deal. Forget all of this right now. Everything here, if there was none of this here, would be nothing but light. There would be light in here because the light is traveling from everywhere else to get to where it's going to. There is no question about that. And they are particles, as I will show you. And because they are particles, they fill this. Now, as I said before, these particles, this whole thing is moving. Well, let me show you how it's moving first, and then we'll go back to this and see how this impacts us. Okay, this is a representation of our solar system going through the Milky Way. So here we are, the sun. Now, it's spinning just like we are spinning to the right because we are concussing this way, and it makes a spin to the right. I can't really be certain of why, but that is the norm. Everything spins to the right. It's called the right-hand rule. If you're spinning this, if you're moving that way, the field goes this way. Now, you can see the sun is scrubbing off particles off it because it's rubbing into particles that are out here. There's particles. There's not nothing out here. There's particles, and they're crashing against us. So we're rubbing through them. That is what creates the magnetic fields on all of these. And that's the reason that way outside the corona from the sun, not on its surface, but way outside of the surface, millions of degrees, because it's scrubbing through the atmosphere, scrubbing. At the surface, it's only 6,000 degrees. Our atmosphere, at our magnetosphere and our ionosphere out in that area, it's thousands of degrees, and on our Earth's surface, it's 90 degrees, something like that, 85 degrees. And every other one is the same way, because they're all scrubbing through the same particles, which I have particles all over my screen. Now, that is the way magnetic fields and energy on the surface of the Earth is created. That's how the heat is created, from scrubbing through this. Now, at a certain point, we have absorbed the electrons we're scrubbing through. It's going to be absorbed into the water, into the, our oceans are probably have increased in temperature. Everything increases in temperature. It keeps absorbing more and more electrons because they're free to float around in there. That's called the ether, which in space is just flat electrons, basically. In matter, there's just a million, bazillions, and trillions of extra electrons in here. When it's hot, they're flooded with them. When it's freezing cold, most of them have gone out. But there's going to be a ton of extra ones still until you get down to absolute zero. Absolute zero means absolute zero extra electrons. No extra electrons in this goose at absolute zero. All right? And I could heat this up to 200 degrees, and it would be hot, and it would get heavier. All right? It does. The more electrons you pump into here, the heavier it gets. Electrons have mass. Light has mass. Light is particles. Let's take a look. Okay, let's just try to understand the galaxy now. You saw the solar system. Now, we are on one of these arms of the galaxy. And why are they arms? And why are they twisted back like that? And remember, let's say that's us right here. Let's say that's our little solar system. And we're coming around here like this as the galaxy spins. And don't forget, it's a right-hand spin. So here we go. We're in front of us. What's in front of us? Well, there's going to be, you can see there's some kind of white-looking stuff. Anytime you see white, that means there's something there. So we are going through something. Now, something that was way out here would be going through less, but I can tell you an absolute fact. There is light going from here to here, here to here, here to there, there to here, here to here, here to here. It's everywhere, 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 everywhere. So get it out of your head to think that you can get outside the light. You cannot. What is the denseness of the light? That is the key. Now, are we in dense space? Or are we in mild space? I don't know. I have no idea. Now, if we're in dense space, we're going to be hotter. And we could go tomorrow to go into dense space. You don't know what's in front. There's dark stuff, there's light stuff, there's all kind of different variations here. And if we're moving through it, well, who's to say? So that's the key. Whatever we rub through impacts us, our magnetic interaction. And literally that's all it is, the magnetic interaction, which creates heat, which creates voltage, literally electronic, thunderstorms and all kinds of things like that. And it adds electrons to the Earth, which is global warming. And you can't really stop that. I don't know of any way that you can stop electrons from being accumulated. Although, I'll tell you, this just struck me. They said that the Sumerians, originally they had come here from Nibiru to get gold to put it in their atmosphere to keep from getting too hot. Now, that would also keep the electrons bounced off, or at least not penetrating down into the atmosphere, because the heat comes from up down. It doesn't go from down up. Like in the sun, it's 6,000 degrees on the sun's surface. And out at the corona, it's millions of degrees. That's miles and miles and miles out. And it's scrubbing through. And you can see the big loops of electricity jumping off and all these magnetic lines of flux. And they say, oh, that's because it's boiling from the fusion inside. Absolutely not. There's no fusion inside. It's the heat coming down from the corona. Millions of degrees. Obviously it's coming down. Same thing with us. Our temperature is coming down from our magnetosphere, ionosphere, the scrubbing area out there. It's thousands of degrees. Obviously it's coming down. I think we just need to really start to think a little bit more about, at least to think these things through. If I'm wrong, I'm wrong. But everywhere I go with this, I keep getting better and better feeling that I'm writing and writer and writer. So I think it's time to see if I'm righter or I'm wronger. But that's all. Costs you nothing to think. Okay, I believe in a minute here I'm going to get it kind of deep into what light is and how it interacts and so forth. But let me just give you a quick idea. This is a pulse red laser. You can see it's accelerating. That is the actual particle. The particles come through the venturi accelerated. They crash and they create these. As they slow down, you can see the particle. You see this? Black and white, black and white. Only the white has energy. The black has no energy to it. And I'm going to show you that in a very extreme close-up. All right, here's the way I want you to think of it. These are the particles that are coming through here. And when they have to force themselves into the venturi, which is a tiny little slot here, that creates concussion of all these particles, bam, 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 and they want to own a field around them. At that point, the black particle, which is part of this same electron, these are back-to-back electrons. Positive, negative is an electron. But only the negative has the explosive power. The black part, you see these little black dots? You see them all over? They just get out of the way. The white explodes, and that was what you see as the glow. The dark is the carrier. So it just, they're together, and they sort of go together, but when they hit something, the black just sort of rolls to the side and then comes back later. And the white one does the job. So to me, that's an electron. And to me, every proton is made out of a mass of electrons. And there's a certain frequency that they vibrate at, boom, and it becomes stable. And a proton is 1837 of these particles, which are electrons, and a neutron, add one more, and it becomes neutral at 1838. So, as you start to go through the periodic chart, instead of 1 and 2 and 3 and 4, you got thousands, 2,000s, 10,000, 50,000, 200,000. That's how many particles really are in each one of these. You know, because they start small. The hydrogen's small. You know, it's supposed to have one proton and then one electron and so forth. But so that would still be 2,000 particles right up in that area. And it starts there. And then when you get up in these heavy particles, woo! So that's why you can have all these isotopes and all of these factors between breaking and making molecules to convert them into other substances. It's the most elegant, fabulous system I could imagine. And the more I look at it, the more amazed I am. I think you're going to find this extremely interesting. A simulated Higgs event from the Large Hadron Collider. That's CERN. They slam huge particles together, which are protons, and they explode them into all of these zillions of particles. For me, a proton is 1,837 particles. We are hitting one particle together, like that, through a venturi. They're going to crush into each other, these little particles, not gigantic ones coming smashing like houses into each other. Now, let's see what also they come up with is this, where is it here? Cherenkov radiation. Well, this is Cherenkov, but they call it electron neutrinos, electron showers. That seems a high-speed voltage electron, which we do. We accelerate our electrons, crashed into non-accelerated space, exactly what we do, creating a shower like a bowling ball effect, and all the pins go flying. And it turns extremely white. Cherenkov radiation is an extremely white, glowy radiation, and then it's filled with these electron neutrinos. They claim that you can't see these, you're never going to find these, very hard, nobody can ever find these. Well, let's see. Don't forget, high-speed electron, accelerated, smashing into something, creating a whole batch of these showers of these round circular fields. Now, let's see what Rod did here. Now, I worked with Rod Warren, and this is, here, let's just take one at a time. That is the light from a red pulsed laser. It's all a construction laser. Same as this, right here. Okay, now, these are the pulses. Well, you think it's like a big pulse coming through. It's not. It's a particle here. That particle, as it comes through the air itself concusses. And these are glowing because the whole air in front of this thing is starting to be pressurized. Anytime you pressurize an electron, it starts to glow. That I can't explain, but the white part of it glows. There's a black part and a white part in every electron. They're head to head. The black is up here, the white is over here, let's say. And whenever they crash, the black just rolls away and the white explodes and glows like hell. All right, right there. You see this? That's that same wave. Remember, it was just coming through here. Pip, 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 pip. Well, what is this? What the hell is going on there? If that was light, which it was and is, what is this? That's stretching. It's either pushing it that way or it's pulling it this way. And I know it's pulling it this way because that is a Venturi. Very well understood. A Venturi creates atomic particles, really. It crashes things into each other until they explode in extreme energy, and you get atomization. Right? That's how the old carbureted cars work. Now they squirt the engine with the gas into it so that it makes vapors. Before, they sucked them through these restrictions called Venturis, and they would come out the other side as atomized gases, just like a vapor, and then it could explode. Now, so we have seen this wave accelerate. You can't possibly miss this. Now, secondarily, what do you see in the center there? That's the particle. Remember I said before, the particle is there, it looks like there's a wave. Well, it's just like a jet fighter going through the atmosphere, identical. It creates a wave-looking effect, but the jet fighters are in the center, same thing here. And that is a particle. You can see them as particle. And I'm going to show them to you in great detail in uno momento. But this right here is those electron neutrino showers. Remember I talked about the Cherenkov radiation, the glowy white, heavy-duty, serious radiation. That's Cherenkov. Then this is right after the Cherenkov. See, this is the Cherenkov. Coming this way this time. This is going this way. This is coming this way. And these are the fields that the particles create as they spin as a high-speed particle. Remember, I said a high-speed voltage, a high-speed, which is high voltage electron, crashing into regular space, which is just normal, there's nothing here before, and creating these bowling ball effects, which is this, going flying through. All right? Those are literally electron neutrino showers. If you could see anything different, I'd like to see how your eyes work. Now, what do we have here? These are the particles. And they're back-to-back electrons. Right? So when you have light coming through, you have basically a neutral particle. It has, this is it right here. Right? So if you looked at it from the top, it's back-to-back. This way it's back-to-back. That way it's back-to-back. They're all back-to-back no matter how you look at it. And they spin, when they crash into other particles that are over here, which are just sort of laying around, they bang off of here and they start to spin. And that's what creates that spinning effect. But when you do electricity, different story. You break these in half. So you just have one in half and the other half. I believe. I don't think the entire thing, like a light particle, goes through the wire of a wire. I think it's a half, but I could be wrong. Now, let's look at a couple other quick things, because it's really amazing what this is. Rod Warren did this. Absolutely fabulous. And here's these Higgs fields. The Higgs fields, the same, the electron neutrino Higgs fields. Here's one of them, and here's a particle that came through this up here. And it came through, and it was a white, it almost looked just like the little cursor here. And it was just a white particle. Oops, you can't see that, can you? Oh, yeah, I guess you can. And then that particle did this over here. See it? And it created that. That is smaller than light. If this is created from light, that is not as big as this. I don't know what to say. but it's not the same. No, so we've seen these particles, and this shows the light is actually spinning to the right, which means it would drift to the left. See, it's expanded down here and compressed up here. So we know it's been accelerated here, and it's starting to slow down. And it's spinning to the right means it would drift to the left. And these are the streams of particles that follow it, I believe. Again, Rod did some fabulous work here, and it's just amazing. And this would have never ever been understood or known. People were laughing at him for doing this. And when I saw it, I knew exactly what it was. Everybody said, "Whoa, what is this guy doing?" Whatever. And when I presented this, I believe it was Stanford. I'm almost 100% certain. Well, every one of them did the same thing. Oh, that could be anything. I'm not interested. I don't want to see this. And I said, I can tell you exactly how it happened. I can explain the whole thing. No, I don't want to care. I don't care. Go somewhere else. And that's about every single thing. Unless you agree with what there's, and then they just say, "Oh yes, you're right. I'm right. I was always right. So have a nice day." There's no engagement to anyone that's outside their realm that brings something forward, and nobody outside their realm is going to bring anything forward like this, because this is what happens to them. They get slammed and destroyed. You can have all the evidence you want. I have DNA certified evidence. I have CAT scans. I have everything. That's a goose. That's a goose's head. So, "Oh no, that's a rock." Yale refuses to look at it. So, "No, that's a rock. We don't want to see it. Don't bring it down here." I say, "That's a bone." No, that's not a bone." "Yes, it is. That's a bone." "No, it isn't. We don't want to see it." Yale, Harvard, every one of them, same thing. And then I have the DNA test to go along with it, and I have CAT scans, and I have every specimen, and I have an anatomist verification. I have everything. So, don't ever expect to get any truth from a mainstream science. It's really, now in my opinion, it's just not a single thing I can find that's right. I see nothing right. You tell me something that's right, not a single thing, zero. They don't know what the earth is made of. They don't know how light works. They don't know how energy works. They don't know how gravity even works. How something falls to the ground, no clue. The magnetic field, why is the corona millions of degrees and the surface 6,000? No idea, totally lost. The sun, same thing with the earth. Why is our magnetosphere and our ionosphere very, very hot, and the earth is, extremely cold compared to that? No ideas whatsoever. They have no idea about this dark energy, dark matter. It's nothing more than what is out in space. It's light. It's on its way to get somewhere. Absolutely incredible. And the Doppler, this redshift? No, absolutely not. That's light slowing down. You can see it speeding up and slowing down. I mean, you just take anything, and nothing is right. So, I guess I'll just leave it at that. I know when I say, "Oh, nothing's right," I know everything and everything's wrong, and I'm so smart. Well, that's not what I'm trying to say. I'm saying that we need to look at the principles, the basics, the underlying basement layer of everything that we know, and start from there and come up. Because they did. They realized it was wrong 5 years ago at least. And I've been following this. I knew it was wrong way before that. And 5 years ago, they knew it was wrong. And now they're finally admitting it. So listen to what she has to say. And what it is this something they used to call, they still call them leptons. And they're the certain size particles, and there's only a certain number of them, and they call it universality. They're universal, and that's it there is. Well, finally they found, no, there's all kinds of things that they never realized before. So it's nothing like they thought. So now they have to really start over. But they're having a hard time bringing themselves to do that. But it sounds like they are, so here she goes.
Well, what that means is that there's something wrong with the standard model. We found the crack, finally, in our understanding of particle physics. There's absolutely no way that we can explain this observation with our current understanding. In fact, the only way we think we can explain what's going on is if there are new particles in the universe associated with new physics processes beyond those that we understand.
All right, which is true. They have no clue. I mean, seriously, honestly, they're just totally lost because they're looking for new particles, like they're looking for one big new chunk or something like this. It's not. Everything is made out of the same particles, and they are these little tiny buggers. And everything, look, see, everything's made out of them. See, they attract everything, even my goose's head. Now, that's the key. Everything's made out of these little particles. So you can have a chunk this size, you can have a chunk this size, you can have a chunk. Every size can be represented here. Now, there's certain chunks that are stable, and those numbers, hydrogen is going to be close to 2,000 particles, and there it becomes pretty stable. And helium is going to be like 4 times bigger than that. So that's going to be like 8,000 particles. And then they go up like crazy from there. Because as you start adding neutrons are 1,838 particles each. There's a whole new way of thinking, and they know this, and they all say the same thing. They've all come up to say the standard model's gone. Case is closed. We got to start over. Well, I've already started over, and I think I can explain it quite well by taking every particle is a single particle, all right? And every particle is a plus and a minus. That's a plus and a minus. We call it an electron. Half of that is the negative, half of it is the positive. The positive does not have any explosive power. It is a carrier. It is in its resting state is the same as the explosive state. It has no explosive state. The white particle part of this, though, in its resting state is similar to the black part. It's just sort of no big deal. But once you smash it into somebody else's white region, they explode. And the harder they hit together, the exploder they explode. That's just the way it works. The white, and I show this very carefully. I think I've already shown it, or I will show it for sure. All right, thank you. I love you all.